Okay, so Google Cloud for Startups. I'm David Grant, engineering team lead at Grow. So this is our story and a little bit of our history and how we use Google Cloud Platform at Grow. So about Grow, we started in 2014, and I think started operations in 2015. We're Vancouver based. We have about 25 people in total so far, growing rapidly. We have an awesome team of hardworking people reinventing banking. We like to have fun too. So yeah, that's some of the fellow growers having fun. So we do a lot of Friday activities. Most of these I think are from our Friday activities, like this one down here. I don't know what we were doing there, but we're always doing something crazy on every Friday. Something crazy, new and crazy from our. Yeah. So what does Grow do? So the short answer is we use cutting-edge software and advanced data analytics to make banking less shitty. So I think anyone who's opened up a mortgage, especially in Canada, or gotten a loan, or opened up a bank account, or switched banks, knows that the banking experience in Canada is pretty shitty. It's not like using Airbnb or Google or Uber, which nobody here really uses. So, but we know how shitty banking can be. I know I've had to go to the branch far too many times to do just minor trivial things, changing my address and stuff like that. So customers don't always want to go to a fintech company necessarily, like a small startup that's been around for a couple months or a year, and give them all their money or get a loan from them, or set up an account with them. So they might want to use the bank they know and trust, or they might want to use a startup. Grow is trying to fill that technology gap between what customers want, which is the brand they know and trust potentially, but having better technology. So we're an enterprise software provider offering fintech solutions to empower financial service providers to become fintech providers themselves. We have a wide variety of products from digital onboarding, online lending, financial education. Financial education's like, we're all familiar with using stuff like Amazon, where Amazon is able to recommend what book you should read or what product you should buy. Or Netflix, which is able to, using all its data analytics, able to recommend which movie you might like. Imagine if you had a service that could tell you what financial product you should have, to tell you how much you've spent in bank fees in the last month, and say you spent hundreds of dollars in bank fees and you could be spending 80% less if you move to this account. So that's the kind of, that's under sort of financial education. We provide a wide range of fintech tools as well, fraud and compliance modules, bank account data aggregation. Think of like Mint or Yodlee if anyone's familiar with those tools, and proprietary custom analytic tools. We have a wide variety of customers ranging from the big Canadian banks to mid-sized Canadian banks to small fintech, Canadian fintech companies. Okay. Who am I? David Grant, Grow's oldest employee, apparently. Grow's second tallest employee, second longest beard at Grow, Grow's most senior engineer and team lead. Yeah, we have a really young company. I love Java, Python, Linux, and of course Google Cloud Platform. I'm a longtime user of all things Google. A little bit about our culture at Grow. It's part of our culture that you can go into anyone's slide decks and edit anything you want, and you're expected to pretend that it's not a big deal.
What were you holding?
What's that?
Was that?
I was holding sandwiches, and this was like 15 years ago, before Grow even existed, before half of Grow was even born. I don't know how they got a hold of this picture. They managed to get a hold of, they're pretty crafty, the people that I work with. We like to have fun. So this is Grow's tech stack. So I tried to order it roughly in terms of what we use the most of, or what's the most important part of the core. So starting from the top, I think the number one thing we use is App Engine Standard. That's how, when we started, that was the very first thing we started with, was App Engine Standard. And the second thing, Datastore. So at the beginning of the company, that was the only thing, was those first two. So we were able to get started really rapidly with those two things. Obviously, like everything Emin said, like those things allow you to get started really quickly. Great for a startup. We are now using Cloud SQL in some cases. It comes in handy when you need to be able to do SQL queries. You can't do SQL queries with Cloud Datastore. So I'll talk a little bit more about that later, but we use a bit of Cloud SQL. We started using Flex. Flex just became GA a few months ago. We've started using it right away because of the many advantages over standard. Compute Engine, we've been using a little bit since the beginning here and there. PubSub, we just recently started using a bit of networking stuff, VPNs and VPCs to connect to financial institutions actually. Key Management Service recently came out a few months ago. We started using that a little bit. Container Engine we've been using a little bit, not really full Kubernetes, but we're running some containers in GCE. BigQuery, we're using Dataflow now. We've used storage forever, but I put it down here because it's something I always forget about. Storage is just something that is there and it works. And I added that last minute actually because I always forget about that it's there. But storage is awesome. Stackdriver, Vision API we use to analyze, we do facial recognition. We analyze users' driver license photos, their selfie photos, also stuff like that. Okay. So just some other things that we use that aren't Google specific. We use all our front end is done in React. We use Nginx for our front end servers that host the all the React stuff. We also use Postgres inside of GCE because when we first started using it, it didn't exist in Cloud SQL. And we also use Docker within GCE. Just sort of drawn it up here and how things are connected. This is our end users, which there's a lot of different types of users. We have the banks themselves are users, the API, there's API users, there's also the end users to the banks and to the other institutions. So this is our front end here. In Compute Engine, we have Nginx. Next layer is our core, which is the symbol is the App Engine symbol for those who don't know. So it's all App Engine here. And then some other, so they connect to some other microservices, and these are kind of available to the outside as well, potentially. Then we have sort of our data layer here, mostly Cloud Datastore, Cloud Storage, Cloud SQL. And then here's kind of our backend data warehousing. So there's a couple reasons why we want to dump it to somewhere else. One is so that for Cloud Datastore, it's so that we can query it using SQL. The other reason is we have several different Google projects for different customers. We want to aggregate that data together, anonymize it, put it all into one place, and be able to do aggregated querying over the whole thing. So this is our sort of the data warehouse back here. And then some of the services we use that everywhere, Cloud PubSub to communicate between things, the logging, which is awesome, the error reporting, and Cloud DNS we just started using recently. We were on GoDaddy actually for our DNS. We just switched over to Google recently, and just a much better user interface and way better than GoDaddy was. So why do we love App Engine so much? Like everything Amin said, very powerful, ideal for startups, really easy to get going. You don't need to think about anything other than write your servlets, write your code, and get it done and push it out to production. Auto scaling, load balancing, it's all taken care of for you. You don't have any servers to manage. You can't even SSH into them if you wanted to. It's completely opaque to you. Security, a lot of it's taken care of for you, including denial of service, distributed denial of service prevention, a whole bunch of things. We've actually recently been audited, and security audits go a lot smoother when you're using App Engine because you're leveraging Google for a lot of these security checkboxes for audit purposes. Easy deployment. You have stuff like cron jobs, asynchronous task queues, distributed logging. Something you don't really think about, but yeah, when you have a bunch of servers and you want to log them all to one place, it's a bit of a pain. You got to set up a remote log server somewhere, but App Engine takes care of all that for you. It also does great log grouping by request and just all sorts of little things that I forget that they're there because I'm just so used to them now. But these things that if you're running your own servers from scratch, obviously it's a pain in the butt to set all that stuff up. Error notifications. I remember when Google Stackdriver just sort of switched on about 4 or 5 months ago. Suddenly I was getting emails saying, you've got an exception in your server. We had our own system do this before where it sent out emails. One of the great things about Google is just, you just suddenly get these new features someday, like you wake up in surprise that you get this little gift of a new feature. So Stackdriver was one of those where I remember one day we just started getting these error notifications. So then I ripped out all the old code that was doing that for us already, which was kind of not perfect. And now we just use Stackdriver notifications, and we didn't have to do any work to set it up. Some of the things that are not so great, there's the dreaded whitelist. I don't know if anyone has run into this, but you might try to be doing an App Engine project and try to use it in a third-party library. You try it in App Engine, it doesn't work because it's using file access. It's using some Java x.security packages or classes. You can't you can't make a connection from App Engine to the outside world with a client certificate, for example. You can't access the key store. There's tons of stuff you can't do, which is not the end of the world. Like, we've always been able to get around it. We can put something in GCE, or we can figure out a different library that does support App Engine. So we've so far been able to work around it. We're still on App Engine, but it can be a little bit of a pain. There's no Java 8, which is okay, I guess. I mean, I've just gotten used to being on 7 now. I've forced myself to be content with it. I did come from a company where I used Java 8 3 years ago. But yeah, it's okay. I'm okay with it. Can't communicate with GC instances over a private network. This is something that, yeah, I mean, as you grow as a company, you might need some other things. You might need some little microservice in GCE, and then you start to think, well, how am I going to connect to that GCE? And it turns out you can't over a private network. You have to connect through the internet. So you have this thing on GCE, you have to secure it. You can't IP whitelist your App Engine. So it becomes tricky. You have to set this thing in GCE and really lock it down. So that's a bit more effort required there than if it was on a private network. And the same goes for the VPN. So VPNs you can do in GCE. You can't do an App Engine, so you got to connect to something in GCE to get your VPN. And so I think this the whitelist, and then this is probably the biggest thing recently. I guess having to have GCE and App Engine being totally separate worlds, that's been probably the biggest not so great thing recently for us. No static IPs. This makes sense because App Engine is just dynamically scaled, and so there aren't static IPs. So we've had to. So some places that we communicate to, they want to whitelist our IPs. So we set up a proxy server in GCE, and we go through that proxy, which is fine. But then again, it's on GCE, so you have to go through the internet to get to that GCE. So again, not something that would affect people if you're on premise. You just have a proxy inside your network, and then go through that. So it's another thing we had to deal with. So one of the things that happened recently was we discovered that we were using a library that was using the Socket API in Google. Apparently the Socket API is actually a custom Google implementation of the Socket API, and it had quotas and a bunch of limitations to it, and it's actually a beta or preview release right now, I think. No SLA, subject to deprecation. We probably should have looked at the docs more closely before, but we didn't actually know necessarily that this particular library was using sockets because it was an HTTP library. We assumed it was using the Java URL connection, but it was using raw sockets. So it's okay. We're switching to URL connection, which is using Google's URL fetch library. So you can always work around everything. App Engine Flex. So we've started using it a little bit. All the same, core advantages that App Engine standard has, the scalability and all that stuff. Great for startups as well. Has Java 8, which is great, and lots of other languages as well. It has I don't know the whole list, but way more languages than App Engine standard. No whitelist, so you can do anything you want, as far as I know. It's flexible. You can, again, do almost anything. You can customize your Docker image. Like, it's transparent to you. If you default project, you don't even see the Docker file. You can then create the Docker file essentially, and then put whatever else you want in that Docker file. You can even SSH into the instances, which I just did for the first time a few days ago, which was cool. So I could play around and run all sorts of Unix commands in on there. Which was good. Which helped for debugging. We were debugging some networking issues, so that was helpful. You can join a GCE subnetwork. We just did this last week. You can then join a virtual private cloud. You can then take advantage of VPNs. You can connect to your customers on-premise through your Google private cloud. So that's cool. Not something you can do with App Engine standard at all. So some of the not good stuff with Flex. It seems like it's more expensive as far as I can tell. It doesn't spin down instances at all as far as I can tell. There's no, so this is the, Objectify is the way you access Datastore. The best way to access Datastore as far as I know. And we use it extensively in our App Engine standard systems. We are not able to use Objectify in Flex. This is probably the biggest reason why we're not able to move our entire standard software over to Flex, is the fact that there's no Objectify support. So we're looking forward to hopefully, maybe the next 12 months would be ideal that eventually does support Objectify. I think the developer for Objectify is waiting for one little thing to be supported in Google Flex for him to port it over. It seems to have a very, very slow deployment time. Minor thing. We're not deploying like every 5 minutes, so it's not a big deal. But it's missing some support for other GCP services, although it seems like every time we go back and look, there's more and more things that weren't supported before and now they're supported. So that seems to be just rapidly increasing. There's no built-in memcache support as far as I know. App Engine Standard has this really great memcache support that just takes almost no effort. We enabled it in about 5 minutes, and every single entity in our system was automatically memcache enabled. So I don't think there's any memcache support kind of like there is in standard. The logging got a little bit worse because you don't have this, in App Engine Standard you can group the logs by request. That seems to have gone away in Flex, so every request and response hitting your system is interleaved into one massive log file. That's it for that. So Datastore. Again, Datastore is our core. I'd say most of our stuff is in Datastore, and I guess maybe 50-50. Datastore and Cloud SQL now. But our original core was all Datastore. So Datastore is NoSQL, has all the advantages of NoSQL, like performance, scalability, schemaless. Google's Datastore is auto sharding, scaling, replication, failover, all that good stuff. Great performance. It does have some ACID transaction functionality as well. Indexes, not the same indexes that you'd have in SQL, but it does have some indexing. Has memcache support. I'd say overall, easy to use. Overall. Quick to learn the basics. And then the last good is it's NoSQL. So like all NoSQL, it's not a standard database. If you're using MySQL or Postgres, you can easily find and hire people that everyone's used MySQL or Postgres before. With NoSQL, there's I don't know how many different types of NoSQL databases. I mean, even if someone has experience like I had experience in Cassandra, coming onto Datastore, it's a completely different database. It's something new that I have to learn. The SQL databases, it's just bread and butter. Everyone knows it. Takes a while to get some of the advanced concepts. I didn't know this stuff or get it on day one or even week 1 or week 2. The stuff about strong, weak consistency, how to get the strong consistency in your queries, understanding the ancestor-child relationships and entity groups and what they all mean and what they're all for, and how do you model your data. It's one thing to model your data with a bunch of objects, but then how to model to take advantage of this ancestor-child entity group stuff. No ad hoc querying like there would be in SQL, so you're going to have to dump your data somewhere else if you want to be able to do reporting. For some applications, maybe you're never going to do reporting in SQL, so that's not an issue. But for us, we do need to do a lot of reporting, so this is an issue. So from day one, we've had to dump it to somewhere else. Compound index limits. So you can't just add. So this is the difference with the indexing in Datastore. Is if you want to have a web page that allows you to filter on 10 different things, and return you a list of items back, you can't really do that in Datastore. The right way to do that would be to create a search index somewhere. And there's a limit of like 200 different indexes. That's it. That's the compound indexes, the indexes that are over multiple fields or properties. Okay. So the big data platform. So like Amin says, Google has a lot of tools for big data. It seems like they added a ton in the last, very recently. I go to the documentation, there's like new tools I never heard of. At Grow, what do? We used to have BigQuery. A lot of BigQuery in the past. Now we have a lot of Postgres that's running inside GCE, again, because it wasn't in Cloud SQL at the time. So that's primarily where we have all our data now for analyzing, and it's our data warehouse for data science and everything. Now we're moving towards using Dataflow to put things into. This is still something we're working on right now as we're kind of changing our whole data architecture. We just recently did some Dataflow work. We now have multiple partners. We need to do anonymization. We need to do all these things. We need to do purging. So we're just kind of doing all this stuff right now. And in the future, there's all these other tools. We know a little bit about this. There's this data loss prevention thing, which is neat. Allows you to strip out sensitive data. There's data prep, which I know a little bit about, which is just it's a tool to help prep your data when you're dumping it to your data warehouse. Dataproc, I know nothing about. I just looked a little bit at the documentation. I didn't really know it existed until recently. I don't know if we'll ever use it, but. And then TensorFlow I threw in here. I don't really have a whole slide for machine learning stuff, but so I threw that in here. So some of the things we learned, I'm coming into the home stretch here. Some of the things we've learned. So Google has a lot of things, a lot of good documentation on how to try things. Just use the documentation, use the sample projects that they have. There's a lot of Git repos that have these sample projects. You can quickly try out a lot of things. Try everything. Set up a Google project. Call it whatever, or use your own personal one or whatever, and just try whatever they have and play with it. There's so many things coming out all the time. Try it. Like I guess the lesson here is like a lot of times we've thought and hemmed and hawed about something. Look at the documentation. It's quicker to just go and try it. Like set it up, deploy a Kubernetes cluster, for example. Don't spend time, understanding all the details of how Kubernetes works. Just go follow the instructions and install it and get it going and play with it. App Engine Standard. So while App Engine Standard is good, I think everyone, for any new work, you should consider App Engine Flex or Kubernetes. It all depends on what your company's doing and what your product is. But it's now that App Engine Flex is GA, I think everyone has to consider it. Consider Standard and consider Flex, and also Kubernetes as well. Same goes for Datastore. Datastore is great, but I think for any new work, consider Cloud SQL. If you are gathering petabytes of data every day from sensors or something, you need to dump it quickly into somewhere, put it into Datastore. If you're not writing data that much, you're doing a lot of reading and you're doing a lot of reporting, you need to plug in standard SQL tools and all these things, maybe consider Cloud SQL. Or do a bit of both like we do. Maybe you start your core in Cloud SQL and then stuff that gets written a lot and a lot of data, put that in Datastore. One thing we've learned is that when we have just from day one, we have a few little servers in GCE. We just needed something really quickly, just spun up something in GCE. And there it is. We ran a few apt-get commands and a few other config files. And then every month, maybe change the config a little bit. And now you've got this kind of server that you can't easily recreate. You can kind of snapshot it and back it up, but you can't easily, if something happened to it or someone went in there and monkeyed with it, you can't really, you're kind of hooped. So avoid that temptation to create those. I know it's hard to because you sometimes just need to do something in 5 minutes, and it's quick to just spin up a server and run apt-get. But there are ways to, I think I have another point about this, but there's ways to do sort of this, infrastructure as code, like Terraform. That's for more complicated stuff, but even just use Docker if you can, or even Puppet or Chef or something if you have to. Resist the temptation to just fire up some server and run a few commands on it. Please check in some script somewhere maybe, so you can easily recreate it again later. With BigQuery, we found, obviously it's not a SQL database, so the joins that it offers are not joins in the typical sense, so they're slow. Create fatter entities. Treat it like a NoSQL data store that it is. Create fatter entities. It'll make your querying much quicker. obviously, I mean, yeah, BigQuery, you have to create possibly multiple, dump the data multiple ways, depending on how you're querying it. It's not as simple as just dump everything to some fat entities. You have to dump it to potentially multiple different entities, but the idea here is don't just map directly one-to-one with your SQL database. You have to consider that it's BigQuery. It's not a SQL database, exactly. GCE with Docker. So this is currently how some of the stuff we do is deployed. We build a Docker container and then we deploy that into a GCE instance running. It's running like a kind of pared down version of Kubernetes, like called kubelet. So it's not really Kubernetes, but kind of. That's okay. I think if I had to do it all over again, I would use Kubernetes if possible, because then you can do stuff like auto scale and help you do we call it roll. When you update the your container, you can get it to roll out version. The word version rollout upgrade. It'll bring up one new instance, new version, bring down the other ones with a load balancer, and take care of all that stuff for you. Terraform, something new I recently found out about that looks really nice. It's by the makers of Packer and Vagrant. So if anyone knows about Packer and Vagrant, the same company, HashiCorp, made this thing called Terraform. It's supposedly the latest, greatest thing in that line of evolution. If you think of Chef and Puppet, and then Ansible, and the other one is Salt. The next latest, greatest thing is Terraform. So their little motto is like infrastructure as code. It comes in handy when you get audited and they're wondering like, where's the configuration for all these things for your infrastructure? And it's nice if you can just say, here's this Git repo. This is how all this infrastructure is. It's right here. It's our change management. It's our everything's right here. This is how where it's defined and controlled. So overall, GCP is great for startups. As you grow, of course, your needs will get more complex, like ours have. You might have to connect to a financial institution or who knows what, or all sorts of other third-party things. And so obviously things get more complex. We started with just AppEdge and Datastore. Now we're using a huge suite of Google products. Google has helped us grow and is very flexible. And Google as well, we're fortunate that Google has been constantly adding stuff over the past 2 years since we started. It's every few months there's something new in preview or beta or something, which is awesome. So it's a good time to be getting onto GCP right now. And by the way, we're hiring, if anyone's interested.